it's great to be back. And see there's only a few people here, but I'm sure, things happen and people will probably join as they arrive. So that's great. So welcome back to night number 2. I hope that you enjoyed last Tuesday night. And if you recall, I left you with a challenge, and that challenge was to take some time out from your day, maybe an hour, get yourself set up with a beverage in a comfy spot with a device, and just explore Scratch. Go into your login and create a project that is exciting to you, interesting to you, and do it not with the thought of this is going to be a lesson, not that this is going to be something I ever show anybody, perhaps just something that hopefully you might get a little lost in, and perhaps learn a lot in that kind of flow that you were in. So I just wanted to start with, before I ask for volunteers to share perhaps what they have created, I want to share first, just maybe as a bit of an icebreaker, one of the things that I do with my students. I have a few students, of course, who are, maybe everybody does, who always want to share. Like there's never an issue. They always want to say what they're doing, but there's others who don't. So I wanted to share a strategy that I use in my classroom to help students share. I'm just going to share that right now. What I mean specifically is to share what they're working on in Scratch currently. So I'm going to share my screen. So what I've done is I've taken an actual, and I haven't got this linked to the slideshow because students wrote this. I did remove all the students' names, and I tried to look through for any personal information. But this is actually something that I posted earlier this week. This is number 3 of sharing the Scratch project. So I create a Google slide. Again, if you weren't here last Tuesday, I teach grade 3 online to students at my school in Peel in Ontario here. And we've been using Scratch. The students have been using Scratch since September. And make a long story short, just since we got back in January, I've been using this strategy because students have more details they want to talk about. So long story short, I make a Google slideshow with a slide that belongs to each student, and the students are to go in and find their name on their slide, and they add 3 things. They add a screenshot of their project page, so just a picture from the project page on Scratch, a link to their project, and then I ask them to talk about their project. So very, very open-ended. I just say, talk about your project. So this is what it looks like. So and I had to take out a few slides because some of the projects had some personal, sometimes they put in their name anyway, and yet, well, that's sort of another issue to talk about to try and get that out. So this doesn't have things where people's names are in them. So some of them decorate their slides, but there's the screenshot, there's the link, and you can see that there's a wide variety, which is great, a wide variety of projects that students are working on. Some of them, like this one, this is one of the tutorials, which I'm going to be pointing out tonight, which I don't think I pointed out last night or Tuesday night. There are tutorials that students can use, and anybody can use, when they're using Scratch to help them get started. So this is one of those, or a remix of one of those. So I'm just going through the different slides so that you can see the variety of projects. This is sort of one of my students who, we'll go back to it. This is one of my students, how can I put this? I guess I can just say it bluntly. He's a bit obsessed with Scratch. He loves it. He goes on and after school, he watches YouTube tutorials about it. And he's 8 years old, and he's basically making 3D games, platformer games, and he's looking at all these tutorials about how to do ray casting, and that's a screenshot of one of his ray casting projects in Scratch. It's somewhat advanced, but he's in what I would call statistically an outlier. But it's always fascinating to hear him talk. So here's some more. These are more typical of the grade. So again, just like I think, was it Lexi who said last week that I was focusing a lot on the math aspects of Scratch and the connections with math, which there always are no matter what you're doing. But I think it was Lexi who was saying that there are lots of other ways that you can connect Scratch all across the curriculum for sure, like storytelling and animations and all of that sort of thing. Science, you could have animations of science concepts or social studies projects, all kinds of things that could be possible. And then I have one at the end. I always have an example. I believe very strongly in being authentic, um, despite the fact that sometimes I pretend that I'm making or I pretend that I make mistakes in Scratch on purpose. But when I do things like this, I literally am learning as well all the time in Scratch, trying to push myself when I have the time. And this is a project that I was working on, so it is authentically a project that I am working on, and authentically there is a bug still in it. But I want students to sort of see that. So this is an example of what a strategy that you might be able to use with your students, and this would work from, I mean, grade 3 and up. You know, just go in Google Slides, find your slide and edit it and add those pieces in. So and I found it to be quite successful. And so this is all editable by all the students in my class. So they can, yes, there's the potential that they could all get in and change things, but that doesn't really happen. So yeah, that is that's one example. So what I'd like to ask now is, are there any volunteers who would like to share their screen, who had taken up the challenge to spend an hour or perhaps more doing some coding in Scratch, who'd like to share any of the projects that they've created? You might have to go into the chat or put your hand up. I don't know. Me, please. Okay. So Manjot, thank you very much. So I believe that this is set up that everybody can share their screen. So if you could at least share your screen with Scratch on it and make sure your mic's on so you can tell us a little bit about your project and what you were working on and so forth. All right, so I can see your desktop and there you are in Scratch. So I just need your mic on, if you don't mind, to show us what you've done and what you're working on. Just so you know, Manjot, your mic's on mute. There you go.
So me and my brother were working on this yesterday, and it's we put some codes in here to make it move like this, like the ball here, and we have to take it to the purple dots on the bat and over here where the glove is too, so we can move it side to side with these type of codings here. And we got these ideas from tutorials on Scratch.
Can you tell us a little bit about the tutorials? Like, what did you look at to help you do this?
We went on to games, and then we went to use arrow keys over here where that cat's flying.
Right. And I noticed that you were able to click games at the top. So you're kind of demonstrating, and that's wonderful, that the tutorials are categorized into different kind of things that you might want to try out, right?
Yeah, it is.
Yeah.
I really like that about Scratch, how it's all organized and I can see what I can do, and also I can create things.
Excellent. That's awesome. And how long did it take you? Can you go back to your code? How long did it take you to put this together?
Well, for me and my brother, while we were working together, it took us a little bit more than half an hour, but less than a full hour.
And have you worked with Scratch or other coding tools before?
Well, yes, because I'm in grade 6 and I started when I was in grade 3.
Started with like just coding or Scratch specifically, or what
I
have
just
you done?
started with Scratch.
Okay, so you've been using Scratch for a little while.
Yeah, I didn't even know what coding was before I went on to Scratch. When my teacher told us about it, I was like, what's that? And then once I started using this, I was obsessed with using it.
That happens, doesn't it?
It does.
So, how much do you use Scratch now like in school? Like, are teachers asking you to use it regularly, or some more than others?
Well, right now, I just got to school actually because I've been doing online school for
Yep.
2 years, so I just came back.
Yep.
And right now we're just like using coding a little bit in like projects and stuff.
Right.
So we are actually using Scratch a lot right now. Every morning we go down to computers and we just spend so much time doing this. And sometimes we even tell our teacher if we can have 5 minutes more and stuff.
So that's great. So is it open-ended? So you can just go down and you can just work on projects that you're excited about?
Yeah, it is. And then like we always just group up and we think of new ideas, and sometimes we even like finish lots of ideas in like less than maybe even 30 minutes since we're so excited about this.
Right on. Okay, well, thank you, Manjot. And I think you're kind of demonstrating one of my points. I don't know if you were here on Tuesday night, were you?
No, I wasn't actually.
So,
I think I
yes,
just came yesterday.
that's okay. So, yeah, I was mentioning on Tuesday night that one of the things that makes kids and students really excited about using Scratch is that it's if you can ask them to work on it and it's open-ended where they can work on projects that they're really excited about in cooperation with their friends and have lots of time and are encouraged to play and share, that makes it really fun and students love to do it.
Hmm.
Whereas instead of say, here's a bunch of assignments, you know,
Yeah.
you've got a bunch of coding assignments and this is due on Friday and all of that. I just find that the other way, making it more open-ended, I find that the people learn more and they learn faster about coding and other things too. Would
Yeah,
you
and it's
think
like
that's true?
fun learning this way. I love using Scratch at school.
Cool. Well, thank you so much, Manjot. I loved your project. Thank you. Just tell us about
Can I
what your
check?
experience, yeah, just you can just tell us about what your experience was. That's okay too.
Okay, thank you. So I'm actually planning to ask the students, so I demonstrate by myself as well, like
Yeah.
how to, when you click the green flag button, that's you have to create one or two sprite and introduce yourself. So it's just a very basic ones. I teach a foreign language Mandarin program. So I'm thinking this could be a really good tool to ask the student um, to to use this technology and use the language skills as well as a mini project. Yeah, that's it. Very simple one.
Are you aware that Scratch users can record their voice as well?
Yes, yes. I'm planning to start actually tomorrow to show them how to record their voice and to add that.
Are you aware as well that Scratch has the ability to translate text?
No, I think there's a globe button, and if you click on it, it translates into different language. That's what I see.
Right.
Um,
So what you're referring to, and that's a really good thing to show too. What you're referring to is if people speak another language and
mm.
they would like to program in Scratch using the interface in that language, they can use it.
Oh,
So
okay.
that is there. But I wanted to make sure I also mentioned down here at the bottom here, the bottom left, there's a blue square. When you click on that, it opens to extensions. There is a text to speech set of blocks that aren't loaded by default, but when you click on that, it loads in these blocks. So you can change
Oh.
text to speech, and in addition to that, also you can, what goes really well with that, sort of like salt and pepper, you can bring in the translate blocks. So you can have Scratch say things in multiple languages and translate them into multiple languages and show the text as well. So it's
Mm.
there are some, this is new for Scratch 3, which is what's on the screen now. This wasn't available in the past, but yeah, this is something else that you might want to play around with.
I think that's really cool. I don't know this function. I'm gonna go and check it.
Yeah, check it out, play around with it. Students, it might be something that might be useful, might not be, but check it out and see what you think.
Thanks, thanks. I
No
will.
problem. All right, one last call for anybody else who would like to share a project that they've put together after the 1 hour challenge. Is there anybody else? Is somebody asking me what did I click on to get to those blocks? Is that what you're asking? Okay. I'll put that back up. So what I clicked on, so if I go back out to Scratch and start from scratch, no pun intended. So going into a brand new fresh project, those colored circles on the left are the different groups of Scratch blocks that always come in, no matter what Scratch project you're working on. However, you don't always want to do things like drawing with the pen or translating a language, so they don't put those in as by default, but you can add them when you go down to the very bottom of that stack of circles. Click on that blue square at the bottom, and then this is what pops up on the screen. All of these are called extensions, and that's just a fancy word for if you want to add more functionality to the basic Scratch project that you have, you can pick one of these. So if you wanted to add music to your Scratch project, there's a music extension. There's a pen extension where you can draw things and you know the sprites move and they can draw. And as I was showing before, there's text to speech, there's video sensing. You can connect a Makey. So if you've used Makey before, Makey is kind of just an external circuit board that mimics the arrow keys on the keyboard and other keys that you have on the keyboard, whatever you want, and you can connect it to your computer and have Scratch interface with the Makey board. If you've got microbits in your school, I've done tons of workshops with microbits as well. They're fantastic. $25 a pop little circuit boards made specifically for kids to play around with and do projects. And so that's actually an actual 3D board that you can connect things to, and you can connect it up to your Scratch project to control things. So anyway, those are the extension blocks, and they just add functionality. So something to really look at there. Checking out the chat. Okay, thank you. Okay. So tonight is hands-on. Tonight, I would like, if you want to, I'm going to go through a second example tonight. And this is another example that I do typically do with my students. And it is an example that's creating a maze game. And I do make some very specific decisions when I'm going through this example of creating a project, because I'm thinking down the road, if students get really hooked on the idea of making games, I want to make sure that they have some powerful ideas that they can build on later, and I kind of introduce them when I introduce the Scratch maze game that I'm about to do. So if that's okay, that's the next thing I have kind of on my list here of things to do. I'm going to demonstrate another game last night, or another project. Last night it was a fairly straightforward project. This is a little bit more involved. And please, if you're welcome to code along with me. I'll share the project at the end. If you would just like to watch, it's up to you. Like, just please follow the style that works best for you. The only thing I probably can't do is if people are all trying to stay exactly keep up, it probably will be impossible to do. So here's the idea. So again, as a teacher, I'm saying to myself, I'm not trying to tell students that they all must make a maze game. I'll always introduce this. Remember that my mantra is passion, peers, play, and projects. So I want my students to be working on projects all the time, not puzzles, not assignments, not that sort of stuff. I kind of do things like that later with challenges where I do work in curricula and I'm looking for various curricular objectives, but students are working on projects. Project-based learning is the key. They're working on things that they're passionate about and interested in. If they're not, I tell them you're not doing it right. I say, if you're doing something and you don't like what you're doing, I say then just leave it. Put that aside. Think about something that's really cool and exciting to you. They're going to work a lot harder and a lot longer doing that. Peers is the third P. Learning as a social endeavor. So sharing, asking for help. What are you doing? How did you do that? That's really cool. You want to work together. Just like was it Manjot? Sorry if I got your name wrong. Who shared earlier. worked with other students in the class, and that was fun. It is fun, and it's learning happens better that way. And play is the fourth P. Play, experimentation, tinkering, experimentation, all that stuff. Hope, growth mindset, all that has to be modeled and expected, and that, in my opinion, that should be the ethos of your classroom when using Scratch and perhaps a lot of other things. So Scratch, my idea is I want to make a Scratch game where Scratch is moving through a maze. He has a start position and he has an end position. So the first thing I want to do is I want to draw my maze. So it's going to be a very simple maze to start. I don't bring in a maze sprite. The sprites are all the things like where Scratch is right now. Those things are the players in the game, so to speak, or the characters in a book. The stage, that has the setting of what you're doing, the backdrops, what's happening in the background. That's where I'm going to put the maze. Now, there are no built-in maze backdrops. So I'm going to paint one myself. So I'm going to click on the stage. Notice how the stage is in blue over here. Here's a little tip if you're taking some notes, if you're a teacher. Early on, students will get mixed up with the sprite, like clicking on the sprite and clicking on the stage. So for example, if I start bringing in some blocks for, thinking I'm programming Scratch, right? See how I'm on the stage? If I go back to Scratch now, almost invariably, I've got 2 or 3 students in the first week or two saying, where do my sprites go? I'm on Scratch. I know I put sprites there, but they're way over on the stage. You can program the stage to do things too. So I just wanted to point that out. If you're taking some notes, that's a good tip to remember if students are like, where do my blocks go? It's very unusual that they would get deleted. They're just probably somewhere else. So I'm going to click on the paintbrush, and when I click on the paintbrush for the stage, I get this great paint program that I can use. It's built into Scratch. So I'm just going to choose black as the background. You can change the thickness of the brush up here. So I can let me make it 18. So I can, yeah, that's thick enough. Okay, so now I'm going to make my my maze. It's just going to be very, very basic at this point. All right, that's it. There's my maze. I'll make it a little bit more confusing by doing this. Not that confusing. Now I want to put a start position and an end position in my maze. So I'm going to go to the circle. You can choose whatever shape you want. Start is usually green, so I'm going to put a green circle where Scratch is going to start the maze. So let me get that over here. My mouse gets sticky sometimes. Okay, so now I'm going to draw a circle down here where Scratch is going to start. Now I don't want that black outline, so I'm going to undo, and it shows there's an outline here. So I'm going to say that I click the red slash to get rid of the outline, the bottom left. Draw that again. If you hold your shift key on the keyboard, it forces it to be a perfect circle or perfect square and so on. And then, as you might guess, I want to have an ending spot. So I'm going to change it to red and draw red here. Good. So now I have a starting spot and an ending spot, and I've drawn it on the background. Now I'm going back to my Scratch cat. Now notice how Scratch is a little bit big for my maze. So the first thing I'm going to do is when I bring in this, I'm going to set. By the way, you can use these plus and minus signs here to make the blocks bigger or smaller. I'm just making them bigger to hopefully that you can see them better when I'm coding. First thing I'm going to do is anything to do with how the sprite looks, or if it says things, that sort of stuff is in the purple. So I'm going to set the size of Scratch to being, I'm going to try 50%. Right away, you're talking about ratios here, but you don't have to make a whole lesson about it. It's all built into what you're doing. And so I'll say things like 100% is the normal size. If I change Scratch to 50%, he's going to be half the size. I'm just using some language, and that's all I would do. I wouldn't bring in any sort of topic, but that's the kind of thing I'm always thinking about as a teacher. I know that there's concepts that are going to be learned here just as a matter of course, but I'm aware of them, and I'm just making sure that I'm explicitly saying a sentence or two with the vocabulary. So now I'm going to check to see if Scratch will fit. He'll fit pretty well, but I think I'm going to make him a bit smaller. I'll make him 40%. and just keep them like that. Now, my next thought is I want Scratch to be able to move up and down and left and right using the arrows on the keyboard. So now what I'd like to do is control the movement of Scratch to go through Scratch.cat, to go through my maze. Now, this is where I make a decision as a teacher that might be different than other people make, but I'm making it for a very specific reason. You can go to events and you can bring in this block here that is already pre-coded when a certain key is pushed to do something. I don't use that block. For at least for this example, and the reason is I'll make that clear when I talk about it. So, but I don't explain this to students either when I'm doing this. I'll say I want to use the keyboard to control Scratch's movement. So what I want to do is, if I push the up arrow, I would like Scratch to move up on the stage. So there are blocks where I can make that sentence with the code. There's an if block. So if the up arrow is pushed on the keyboard, then I want Scratch to move up on the stage. So here's my if block. The sensing keys are the light blue keys. That's where that's connected to things that are connected to the computer, or things that the sprites are the sprites touching other sprites. Is the mouse arrow moving? All the things that are sensing, all the things that might be happening to a sprite or in the environment on the stage. So there is one down here that says if a certain key is pressed. And you might wonder, well, why is that there? And also this one here, where there's the event one. It's just different ways of approaching this. But I think you might see the facility of this when I explain it. So I'm going to move this diamond block into the if block. And it says space right now, but that little arrow beside space allows me to pick any of the most often used keys. You can't pick any key on the keyboard, but you can pick all the letters, numbers, and the arrow keys. So I'm going to click on up arrow. So if key up arrow is pushed, then what do you want to do? This is where I make kind of a mathematical move as a teacher. I want students to know that X means left and right and Y means up and down, because unbeknownst to them, there is a Cartesian coordinate system behind the stage. The very center of the stage is the origin, and we have all four quadrants, and you can see the X, Y values that are there. Students don't really notice those at first. But I just want them to get the idea in their head that X means left, right, Y means up, down. So Y is up, down in Scratch. I don't know why, it just always is. Y is up, down. So if the key arrow is pressed and if the up arrow is pressed, Scratch needs the Y has to change. Y has to get bigger. So we go over to where the motion blocks are, and there is a change Y block. So I'm just going to clunk that in, and it says change Y by 10. I'm going to click that on there like that. And again, this will be a time where I would make a mistake on purpose. I know that this has to be in a forever block. It has to continuously watch the keys and always respond. But I'm going to click the green arrow and nothing happens. So this is where I might introduce the idea of this is like, you know, I think I've coded it all correctly and it's not working. I click the arrow, I push the up arrow and nothing happens. And then I might say something like, the code did exactly what you wanted it to do. As soon as you push the flag, it set the size of Scratch to 40. It checked to see if the arrow was being pushed at the exact moment you clicked the flag. Was the key up arrow being pushed at the exact moment you clicked the flag? No? Okay, then it didn't change Y by 10. It in fact did nothing. And now you're done with your script. There's no more blocks. You're done. The program is finished. So if you want it to continuously, always watch to see if that key is being pushed, you must put in a forever block. So that's something that students learn right away, that now when I push the green flag, you'll notice that the script, the code blocks are glowing with a yellow outline around them. That means that the program is still running. Even though nothing's happening, it's still running, and it is checking like 1,000 times a second if that up arrow is pushed. So when I push the up arrow on the keyboard, Scratch moves up. I can't get Scratch down now. So sometimes I might say to students, so how do you think I should get Scratch to move down? And more often than not, there's a lot of ideas where, well, you need another if block, and you need another sensing block. And this one needs to be code. Now we're basically saying what happens when the down arrow is pushed. So if the up arrow makes y bigger, so moving up makes y larger, if we want to move Scratch down, we have to make y smaller. So what operation are we doing if we're making a value smaller? So again, introducing mathematical terminology, or not so much introducing it, but using mathematical terminology in an applied and authentic way. Students will respond by saying takeaways, minus, you're subtracting. So again, we're talking about up, down. So that's y. And if we want Scratch to go down, then we have to say change y by minus 10. So to go down, they know that y has to decrease. If you're going up, y increases. That's the basic idea. That's all that I want them to absorb right now. They don't have to know about what the Cartesian plane is or any of that stuff, or why we have x, y, or anything. But now the up and down arrow keys are now coded. So they work, but the left and right keys do not. Depending on the students, depending on, like, you know, when you're in front, when you have a bunch of students with you, you get a sense of, is that enough talking? Are they ready to go in? And so sometimes I'll say, I think you've got enough here to remix my project and get Scratch moving left, right, and then maybe doing more with the maze. Sometimes they need more of demonstration. And I'm just going to do that now because I don't really have an authentic class of students right now. But basically, it's 2 more if blocks, 1 if block for each of the keys. And by the way, just as another tip, if you're writing them down, yes, you can duplicate blocks. If you'll notice, these 2 blocks that I used are almost identical. The only difference is the up and down arrow key and the minus sign in front of the 10. You can right click on sort of at the corner, top corner of the blocks that you want to duplicate, and you can make a duplicate of them. And that comes in really, really handy if you are putting together a big project and maybe inside your if block you've got 13 blocks and you need to use those over and over again, but with slight changes. Instead of bringing them all in again 13 times, you can just duplicate the whole thing and just change what you need, but keep everything else the same. So yes, you can do it that way. So if I were to do this the same way, I can duplicate these blocks again. Then I change this to left arrow and right arrow. Absolutely no way I'd be going this fast with students, but I'm just demonstrating for you that this is something that is possible to do. And so now when I use the click the green flag, you'll notice that Scratch moves up and down with the left arrow, up and down with the right arrow. Why is that? And anybody want to know why? Like, anybody want to tell me why? Why is it that when I push the left and right arrow, Scratch is moving up and down? And when I push the up and down arrow, Scratch is moving up and down. Why isn't Scratch moving left and right? Any ideas? Right, it still says Y and it does not say X. I do see another question there, which I'll get to. So X is left and right. Now, somebody said, please explain why we use the forever block. So the forever block, it's a loop. And what it does is it starts, when you use a forever block, anything in the forever block is repeated in the order in which they appear. So all of these blocks here, these 4 if blocks where I have each of the keys programmed, if I don't have them in the forever block and I put them in like this, when I push the green flag, my program ends almost instantly. It's done. It's not running anymore. I push the arrow keys, nothing happens. So when I push the green flag, it checks to see if the up arrow key was pushed first, then it checks to see if the down arrow key was pushed, then the left, then the right, then it stops, and it does all that in less than 1,000th of a second, because that's what I told it to do. So I only told it to check those keys once immediately after that green flag was pushed, and then it's done. But in a real game, or in a game, you want those keys to always be working. You want the up arrow to always, I mean, it could say always instead of forever. You want it to always be checking to see if the up arrow is pushed. Chris, did you have a question for Oscar? Some people have their mic unmuted. I just didn't know if people were wondering with a question. Okay, no worries. So I'm going to put the forever block around it. And when I click the flag, it glows yellow. And that means that, so now I've got my arrows incorrect. So this has to be right. This has to be left. So the right arrow, left arrow, up arrow, down arrow works, but now we have a problem. So this isn't a maze game yet. Scratch can just move right up to the red. It's no fun. Well, where's the fun of this? There's no skill. So we have to make it so that there's some sort of penalty for touching the wall. We either have to make those black lines real walls that the sprite can't move through, or we have to make something happen. So probably one of the easiest things to do is just make it so that if Scratch happens to touch the black wall, sorry, you got to go and start over again. So again, that's another if block. So again, if Scratch is touching the wall, then send him back to the start. So I'm going to put in another if block. If you go to sensing, there is a one that says touching color. It just so happens that my walls in my maze are black. So I'm going to move this in. Right now it shows a purple. There's no purple in my project. But if I click right on the purple here, I can set the color to black, or even better, I can use what's called an eyedropper. So when I click the eyedropper at the bottom, now it's the little tiny square in the middle is picking the color that it's looking for. So it'll change into a circle around the outside in a ring. So I want it to look for this black color. So now I've set it to black. Then that's really helpful if you're not sure what exact color you set it to, you can't remember, you can just use the eyedropper. So if the sprite is touching the color black, I want Scratch to go back to the beginning here. There is no block that says send Scratch back to the beginning because I made the beginning. I made the green circle when I did the background here. So Scratch has no idea what the beginning is. I have to define what the beginning is. So I'm going to say the beginning is this position on the stage. So remember how the stage has a Cartesian coordinate system. So this is where I would also introduce the idea that every single tiny point on the stage, and if students don't think they're points, I tell them to go really close up and look at their screen. If you go really close, you can see that everything on your screen is made up of little dots, little tiny dots. So every single dot has an address. So when I put Scratch right here, it shows the address in the XY here, X minus 205, Y minus 147. But it gets even easier than that. If I go to motion, the go-to block here always has the current position of the sprite. So if I were to move Scratch up here, now the go-to looks like that. If I put Scratch down on the green where I want him to start, the go-to has now the current position. So now I'm going to put this here. Done. If Scratch touches that black wall, boom, you're set right back to the beginning. So here I go. So now watch, I'm going to touch the wall at the top here. I'm going to go down, sent back to the beginning. And if I push the right arrow now and keep on trying to hit the wall, see what happens? It just keeps on being sent back. So now there's actually some skill involved. You have to use the arrows and he has to get to the end. He's got to fit through here. Oh, I touched the edge. So here's where it starts to get a little bit fun. So you have to try and be able to do this. Now, I want something really exciting and fun to happen when Scratch gets to the red. So just like I have if touching the color black makes something happen, I want something exciting to happen if he touches the color red, because that means he got to the end. So I'm going to duplicate this block and take the go-to out. By the way, I did that really fast. In order to delete a block, you can leave a block over here if you think you might use it later. If you want to keep your script area sort of neat, you can just you basically return the block that you don't want back over here to the blocks, and it will immediately just sort of disappear. So that's how you do that. So now I want to grab the red color. So if touching color black, no, I don't want that. Go to the eyedropper, grab red. If touching the color red, then I want it to play a really cool sound or a song. So I'm going to go to the songs. These are all built-in loops. If you hover over the purple circle, it plays them. Now I want a loop. I want like a loop that plays something. So I'm going to go up here to loops. These are all just musical, little short musical loops. That was good. I'll use that one. Just a little note here, if you're keeping some notes as a teacher, just like you can edit images, like I painted the background of the sprite, I painted the walls of the maze. You can also edit sounds, like this goes a certain speed. I can slow it down. I can make it fade in and fade out. So no, this is not like GarageBand, but there are basic things that you can do to sounds to do a little bit of editing. And you can do things like cropping really easy. So if this is too long, I could say I want this to sort of maybe end there. So I want to delete that. So I can push delete, and now it's a little bit shorter. Okay. So then I'm going to go up to where it says sound, and I want it to play sound techno until done. The difference between these two, the play sound and play techno until done, the play sound techno, sorry, it will start the song, but it will continue with the next block. So if you want things to happen as the song is playing, you want to use this one. If you want the song to play and have the entire project stop and only the song play and nothing else happens, you want this one. And I want that one right now because it's the end and you've won. I can also make Scratch say, yay, I got to the end. So I'm going to go down and have Scratch say something as well. So I'm going to have him say, yay, I got to the end. All right, so here we go. Test out my program. Now, what I'll do is I'll say to students, you know what you can do if you're just testing it and you don't want to, like some students might make a really complicated maze and they say, I don't want to spend 3 minutes getting through my maze every time, I want to test it. But you can just drag Scratch right near to the end and then, move them over to the end. So that you're in this is the coding phase, right? So you can skip that part. So it won't ever stop. And the reason why it won't ever stop is because the thing is in a forever loop, and it says if it's touching the color red, then it's going to continuously say, yay, I got to the end, and play the techno loop. Okay. So this is basically, I'm done now. And this would be a point at which I would say to students, remember, you should always give your project a title. So we'll call this maze number 1 up at the top here. If it says save now beside the little file folder at the top right, make sure you click save now. It auto saves, every minute or two. I can't remember exactly when, but then I can go now to my project page by clicking on the folder. Actually, I can go to the project page here. It's right at the top center. So this is the project page for maze 1. So somebody can come along, and if I shared this project, which I haven't yet, nobody can see this but me. If I shared this, somebody could come along and play my game. They could leave me a comment at the bottom if I've shared it. I can turn comments off too. They can remix it. They can say, oh, this is an interesting maze, but I'm going to make it easier, or I'm going to make it harder, or I'm going to add another player so people can race. Let's see who can get to the end first. So they could add a second sprite and maybe control the sprite with WASD, the movement keys for Minecraft. So one student sits on the right side of the keyboard, one student sits on the left side of the keyboard, and they can race to try to get to the end of the maze. So there's all kinds of really cool things that they can do. So, but this is where I would just say under the instructions, use the arrow keys. And students love this. I mean, this is project-based learning. They've made their project. They've got instructions for the user. They can put in notes and credits about their game, thoughts about what they want to do next, asking for suggestions. What do you think would be a great level 2? I want to do the next level, next week. What should I do next? So use the arrow keys to control Scratch moving through the maze. And yeah, so I could put in other notes here. I don't have anything really to say. And then when I click, I might say down here, this is an example for UBC workshop. Because this can be notes, this can be credits or whatever. Can you explain how a student can share with a different student in the class and then how you can remix? Yes, very good question. So when there's a magical button at the top right here. It's an orange button that says share. It only appears after a student creates a Scratch account and then goes to the email that they used to create the account and say verify. So whether you're teaching online or in class, you might have students say, I can't share, like it doesn't let me share it. It says something else. Usually it's because they haven't verified their email. So once they verify the email, they have the capability of share. So now when I click that, that orange share button, there we go. It says your project is now shared. Now a whole bunch of stuff happened. The comments box opened up at the bottom because commenting is turned on by default. There's a place where I can copy the link, the heart and the star, all that become active, and it's now shared with 85 million Scratch users. So if somebody is using Scratch, they can come, one of those 85 million users can come and look at my game. Probably they won't because there's nobody gets notification that I've just posted anything unless you're kind of following me. And so this goes to this question, how can students share with different students in the class? Remember way back on, if you were here on Tuesday, down on slide number 17, this was another strategy I use in my class. And I've done this with classes of any grade. As long as the requisite permission forms have been signed by parents and all that, all you've done your digital citizenship due diligence, et cetera, all that stuff's taken care of. I have a shared Google Doc and I shared one with you on slide 17 where people could put in their first name, and this is only accessible to the students in the class. So they can then see everybody's profile link here. So at the very beginning of the year, let's say Lexi, thank you Lexi if you're here. Let's say Lexi is another student in my class. I'm going to go follow Lexi on Scratch. So I'm going to click on her Scratch username and click there. This is Lexi's Scratch site. So now I'm going to click follow at the top here. So now I'm following her. And now when I go to my page, if I go to mine, if I scroll down here, people that I follow on Scratch, things that they have created will appear on the main page. So let's go down here. This is the main page of Scratch. So I was on my profile page before. This is the main page. So when I click on the Scratch word at the top, if you go down here, it says projects by Scratchers I'm following. So if I want to just see what are some of the latest projects from Scratchers that I'm following, they will appear here. If you want to go and see, what projects has Lexi done recently, then I tell my students, go to this Google Doc, find who you want to see their project of, or Lexi could say, hey, go look at my project. And then they can go to this doc, click on her profile, and then they can see this shows all of her projects. So Miss Tucker made this Scratch project here. She made it quite a few years ago in January 2018. It shows it down here. So there's her project that she made. So I'm gonna click favorite or like and favorite. Now, if I want to remix her project now, so some TS says, can you explain how students can share with another student and then remix it? This is now somebody else's project. I know right away because there's a green remix button there. If I click remix, here's what happens. It takes her whole Ms. Tucker project, copies it, duplicates it, saves it in my project area, and now I can edit it. I'm not editing her original project. It made a duplicate, and now this will now be a remix. So now I can go through and I can do different things to her project, and she gets a notification that Jimmy C remixed her project, and she can see my remix. She can see what I did. So I can, one thing I'll do, I'll just do something really quick here. So it looks like I remixed it. For the T, I'm going to change the whirl effect. So watch. Why is it? Oh, when the T is pressed. Okay, so here's another thing I'm going to remix. I'm going to make it so that it's the flag, not the T. And she has that for all of hers. So, you know, here's a remix. So instead, I'm going through and I'm changing all of this to all of these letters will do something when you push the flag instead of having to wait to push the letter. It's not a criticism of it. It's just like, this is my idea for this project. She still has her own project. Now when everything happens at once. So now I've saved her project in my space. So when I go to my stuff, you'll see up here, Ms. Tucker Remix. And when Ms. Tucker logs in next, she's going to see on the bottom right-hand side of that original project that, oh, Jimmy C remixed my project. And she can actually go to it and see what I did. But I have a duplicate of hers. When students are working with their own account rather than within a teacher account, is there an ability to share only with specific people? Good question. I don't think so. I don't know for sure, but I don't think so. Like I said on Tuesday, I had explored teacher accounts, but I don't use them anymore. I want students to be able to use Scratch beyond the year that I teach them. And that's a really good question. I don't remember. I don't think so. I think the teacher accounts just give the teacher the ability to reset passwords, control, like kind of have a few more classroom controls, make the accounts all themselves so everything works right away. Students don't have to sign up and all of that. So I think that's the answer to that. But ultimately, I'm not absolutely sure. Great question. Please, if you've got other questions, please put them into the chat. I'm happy to talk about that. If anybody is working on a project, or if you've coded along with the maze, I would love to see. I do have a couple other things that I wanted to point out from my from the resource I had from last week, which I'll put the link to in the chat. So this is the resource that I put together. There's a bunch of stuff in here that you might find useful if you're a teacher wanting to use Scratch. The last two slides, the second to last slide, are some creative learning resources. So this is creative learning, it's creative coding. That's juxtaposed with coding where it's based on lessons and assignments and things where today we're going to learn about how we use we're going to use the move blocks today, and then tomorrow our lesson is all about these blocks. I've done that, and it gets dry super quick, and I lose students fast. I find that it's just my experience, but I find that it's much better if students want first have a desire and a need to do something in the project they're making, and then they learn, oh, okay, there's a block that does that, and through asking and experimentation, rather than just showing all the blue blocks and what they do. So anyway, these are some creative learning resources. I really wanted to recommend, if people want to do a deep dive into creative learning, the Media Lab at MIT has a learning creative learning online course that is 100% free. It's not running in terms of there is a place where you can put comments and discussions. I don't know if there are people actively doing that right now, but all of the materials and content are all there ready to go. So they are saying that there is a new round of the course starting, and you can sign up to receive updates. So if you want to be part of a cohort who are taking this and you want people to talk to, then you can do that. But I can go immediately into an introduction and away we can go. So I do want to play the first maybe 4 minutes of this introduction. This is Mitch Resnick, who runs the Lifelong Kindergarten group at MIT. He was the lead, along with Yasmin Kefai and a few other people. Don't know if my video is on, if you can see this, but Yasmin Kefai and Mitch Resnick wrote this great book called Constructionism in Practice. If you're an MET student or another grad student or even undergrad student or a a person who is in teacher education currently, this is a great book to read, Constructionism in Practice. I'm happy to share. That information is in my slideshow as well. So let's watch the first maybe 3 or 4 minutes of Mitch Resnick. But first I'm going to look at the chat here. Is there a way to reset like in Scratch Junior? For example, draw with the pen, test the program, and clear the stage. Oh yeah. Thank you. I'll get to that right away. I'm definitely going to respond to questions and comments in the chat before I do anything else, because that's most important. So let me go to a project that I was working on before, so I don't have to start from scratch. So I'll go to my maze. Actually, no. I'm going to bring in the pen blocks. If you want to be able to erase the screen, you can go to the pen blocks, bring in the pen extensions. There's an erase all block. And it's cool that the extensions all have a little icon in front of them. So this has a little pen there. So if Scratch, let's say I want Scratch to draw a little circle here. So so when Scratch is moving, and this has a really interesting story. I've done this with grade 1s where they're not doing the coding, but we've all pre-COVID times, pre-pandemic times, we've all stood around on a carpet and we've had somebody stand out in the middle of the carpet and I'd say, walk in a circle. So one of the students volunteers, they walk in a circle and I say, make it a bigger circle. So we're all standing around the edge of the carpet. So make it a bigger circle. So they walk in a larger circle. Okay, now slow it down. Do it in slow motion. No, even slower, even slower. Even slower. So what we do is we start analyzing that movement of the child who's walking in the circle. And quite quickly, you might be surprised, but quite quickly it comes down to, well, the way they're moving is they're kind of moving a bit and then they turn a little bit and then they move a little bit and then they turn a little bit and then they move a little bit and then they turn a little bit. And they're always turning kind of in the same direction, then they move a little bit more. And that's actually what's happening. When you slow it down, the students sort of see that that's happening, because I'll use terms like, they're moving like a robot. So think of it that you're telling the robot how to move. So here's Scratch, and I'm getting to the pen and the erase question. I just thought of another way of demonstrating another idea here. So here's Scratch moving a bit and turning a bit. And then he moves a bit and he turns a bit and he's repeating it. So he's going forever. So there's Scratch moving a little bit, turning a little bit, and it's in a forever block. So Scratch is going around now. It just looks like he's going around in a spiral. So what I'm going to do is I'm going to turn it a little bit, the degrees, make the turning a little bit less, and maybe make the walking a little bit more. So what you can do, whoops, let's stop him here. Let's get him up here. So what you can do with Scratch is you can tell Scratch with the pen blocks that you want Scratch to put the pen down. So here's the pen down block. And then I'm going to push the flag. And here's Scratch moving around in a circle. Right away, like I've done this lesson with kids of all ages. That's all I've shown. I've said, okay, you guys have been using Scratch for a few weeks now. There's like, start bringing in blocks and see what happens. So I've had kids go in and then they'll go, here's a block that says go to a random position. So they might bring in a repeat block, get Scratch to draw his circle. Oh, look, he's not erasing. I want it to be a blank slate at the beginning. So now here's where I can bring in the erase all and put that right at the beginning. Then it starts from a blank slate, but it's erasing every time. So the erase all is what you can use. So here's Scratch going around, making a circle. Let's get him to finish with 40. So now I want him to go to a random position, and then I'm going to put all of that inside a forever block. So now Scratch is going to move to all these random positions, but look, every time he moves to a random position, the line follows him there. So before he moves to the random position, let's put the pen up. So we'll put the pen up, go to the random position, and then put the pen down. So now he's just moving around. And here's one more really cool thing if you're making some notes. See how it's taking him a while to draw the circles here? If you push the Shift key and click on the green flag, It's called turbo mode. So here's what will happen if I do that. Okay. Yeah, turbo mode is fast. Turbo is really, really fast. So it basically will compress something that might take, 6 hours to do into a second. So it does it really, really fast. Why would you want to do that? Well, sometimes you might be working with things where you want it to refresh on the screen really fast and make it appear that it's animating. So, and that's sort of an example for another day. Where on a student's page do we find our link to the class Google Doc? Okay, gotcha. On the last screen is the ready to go resources that I talked about last time, but I wanted to show you the Learning Creative Learning video from Rich Resnick. So this is, he's echoing what I said. Actually, I'm echoing what he said when he talks about project, peers, passion, and play, a constructionist approach and a creative approach to coding, treating coding as a literacy, not so much an isolated skill. I really do conceive of it like you're learning another language and all the things that go along with it, or learning to play a brand new instrument and all the things that go along with it. It's not something that happens fast. It happens slowly and takes a lot of time. Anyway, here's Mitch introducing his course.
Hi, I'm Mitch Resnick, Professor of Learning Research here at the MIT Media Lab, and I'm one of the organizers of the Learning Creative Learning online course. In this course, we'll be exploring the what, why, and how of creative learning. What is creative learning? Why is it more important now than ever before? And how can we support and encourage creative learning? I can't think of a better place to start our exploration of creative learning than here at the MIT Media Lab, which has earned an international reputation for creativity and innovation. What makes the Media Lab such a hotbed for creativity? The key, I think, is that the Media Lab is run somewhat like a big kindergarten. Think of a traditional kindergarten. Kids are playfully creating things in collaboration with one another, making castles out of wooden blocks or pictures with finger paint. In the process, they're learning about the creative process and developing as creative thinkers. Here at the Media Lab, the tools and building materials might be somewhat different, but the process is the same. Students are playfully creating things in collaboration with one another, and that helps them develop as creative thinkers. Now, unfortunately, if you walk into most elementary schools or middle schools or high schools, you see something very different. Often, kids are sitting in desks, listening to lectures, filling out worksheets. The focus is on delivering information or delivering instruction. This approach is even seeping down into kindergarten, where kids are looking at phonics flashcards or filling out math worksheets. In short, kindergarten is becoming more like the rest of school. In my research group here at the Media Lab, we're trying to do exactly the opposite. We want to make the rest of school, in fact, the rest of life, more like kindergarten. So we call our group the Lifelong Kindergarten Group. Let's go inside and take a look. The goal of our Lifelong Kindergarten Group is to provide all children of all ages, of all backgrounds, with opportunities to design, create, experiment, and explore, just like kids in kindergarten. Our approach we sometimes characterize with 4 words: projects, passion, peers, and play. We apply these ideas to everything we do. We try to provide opportunities for kids to work on projects where they start with the inkling of an idea and carry through to a finished project. We encourage kids to follow their passions because we know that they're going to work longer and harder and persist in the face of challenges when they're working on things they really care about. We support kids working with peers because we know that learning is a social process, not just an individual endeavor. And we encourage a playful approach to learning, where kids are constantly experimenting, taking risks, trying new things. We've applied these ideas to lots of different projects over the years. For more than 30 years.
So that's the beginning of the Learning Creative Learning course at MIT. And again, that is a free course for anybody, and it is linked in the slides that I've shared with you in the chat. So if you want to take a copy of that, you can. Remember, in the slides that I have here, I haven't talked about everything that's in here, but I do have a section here where I do have some examples of Mathland ? And if you were here on Tuesday, the idea was, how could we make experiences that students have in school more like an immersion for mathematics or other subjects, but I'm sort of more focusing on math here. If you want to really learn another language really, really well, you need to immerse yourself in it, and actually immerse yourself in it in the culture where that language is active, rather than, say, going to a class. It's better than nothing if you don't have access to the culture and can't live there for a long time. Going to a class is great, but you won't learn as much about the language and the culture than if you actually were there and truly immersed in it. So the idea is how can we do that with mathematics? How can we immerse children in a mathematical land? And a lot of the researchers in this research, they call it math land. Seymour Papert did in a number of his books. And again, his video, a little clip is here. And his book from 1980 is called Mindstorms. The full text is available for free online. It's his estate has allowed it to be accessed for free. So that's kind of the seminal book on constructionism and allowing children to use technology, to be in control of the technology, to learn and think and create with, rather than the other way around, rather than the technology delivering information, like Mitch Resnick was saying. So Scratch was designed to do just that, to be a place where it's a playground for children, where they have a place where they can play around with blocks and projects and ideas. And in the process, they're in a world called Mathland, where math is the way everything works, and they're going to learn it through an immersive process. And that's like what I was saying on Tuesday. I have students, I'm in the middle of grade 3. We're at we're beginning of February now, so we're over halfway through the year. My students use Scratch at least 3 times a week for about 40 minutes to an hour each of those sessions. They always include sharing time as well. They're becoming much more literate with Scratch, and they're starting to talk about mathematical concepts like variables in terms of what they've done in Scratch, rather than variables are X and Y and it's a value that you don't know. If I say, what's a variable, they'll say, oh, well, I used a variable for my score in my game. There has to be like a container to hold the score. And that's a word that I introduced early in the year. A variable is like a container that holds a number, and it can change. And that's essentially what happens, say, with a score in a game. A score is a great example, real life example of a variable. So students are thinking about that. So that's about it. I'd like to leave you with a few thoughts, and that is using Scratch. You can use Scratch in any way that you wish, but the ways that have been the most effective for what I've done with students is to have that mantra of the 4 Ps, the passion, peers, projects, and play, and to have an environment in which they're creating projects, give them ample opportunity and time to share. There's in that slideshow, I do have a slide on constructionism and what learning conditions in the classroom need to be present for it to work really well. Those are my ideas for what works for me. And I think that's super, super important. So the other thing is that Scratch can grow along with students. They can start off with very simple projects. It's got an extremely high ceiling in terms of the complexity of the programs can become extremely complex, and it will grow along with them, no problem. It also has something called wide walls, in that there's not sort of a narrow kind of, you can do this project or this kind of project, this or this or this, and that's about it. The students, there's ample ways that they can personalize and customize and make it exactly the way they want. They can upload their own sounds, pictures, draw their own pictures. So many things that they can do to make it exactly the way they want it to be. So a huge variety of ways that they can make their projects, and projects can be extremely simple and straightforward or highly complex. So I believe it's probably one of the best tools out there for this type of endeavor. And if you want kids to learn how to code, if that's what you want them to do, they're going to learn how to code, but they're going to learn how to code. My kids learn how to code far better when that's not my focus. I know it's going to happen. It doesn't mean it's not going to happen, but that's not my focus. My focus is creative learning, creative coding. My focus is project-based learning, making sure that they're excited and passionate about what they're doing. And with that kind of a focus and in introducing lots of times to share and work together, they've learned far more code competencies than where if I did it, say, at a lesson-based system. So anyway, thank you very much. It's